9, sequences. 9.1, just kind of introducing you to the concept of sequences and what they are. It's actually kind of a tricky assignment because it has a variety of sequences that make it so that you have to play around with a whole bunch of different types of things going on. The main thing we're going to worry about is section 9.2 and 9.3, where we focus in on specific types of sequences, and that will be much more important. So the main thing we need to accomplish here is understanding some notation that's a little bit different than what we're used to, etc. Okay, it's hard to write and talk at the same time when I'm not writing what I'm saying. Guess you're used to watching that though. Okay. Sequence. A sequence is a function whose domain is the positive integers also known as the natural numbers. Natural numbers are also referred to as counting numbers. So when you count, you're using the natural numbers, like the number always starts at the number 1 and goes up from there. Okay, so that's the domain. That's always the number you plug in. But instead of using x for the domain for that, we usually use the letter n. Not always. But n refers to, I think, the fact that it's a natural number. So that helps us remember that we're plugging in those natural numbers instead of anything. X is more typically used when the domain can be all real numbers. Okay. When we if we were to graph sequences, which we're not going to really do, but if they were graphed, we would not have a nice continuous graph, but rather it would just be dots. If graphed, there would be dots for each value at the positive whole numbers instead of a continuous line. So no such thing as fractional parts when you're graphing them. Your x value cannot be a decimal or a fraction, it's just those positive whole numbers. Okay, the notation we use then is a little bit different than what we're used to. So I already told you this, domain, we use n instead of x. And n equals 1, 2, 3, 4, 5, 6, etc. The range, typically we're going to use the letter A. Instead of y. Okay, so what's going to end up being, what's going to happen here is, like, if I tell you that I want, I'm talking about a sub 3, so we would say this, a sub 3, means the third number in the sequence, or the number you get when n equals 3, because it's the third number and you always start at 1. Okay, so this little sub 3 is an index number. It's just telling you the name of that number in the sequence. It is not, there is no math to be done with that number 3 typically, unless it requires us to know that n also equals 3 and we end up plugging that in somewhere. But just keep in mind that that's just like a name for that number in a sequence. Okay, just a quick review before we get into some serious what sequences are and look at some examples. Okay, first of all, we need to review what a factorial is. Does anyone remember that? Factorial, you might see something like x with an exclamation point. Okay, there's typically a button on a scientific calculator that will allow you to do that. If you do 10 factorial, that means 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So if you can find that exclamation point on your calculator, it's a shortcut way of being able to do something like that, which does come in important when we're doing some things with sequences. So I just wanted to review and make sure you knew what that meant. For example, also sometimes we'll take factorial problems and divide them, and it's kind of interesting what happens, because if you divide 12 factorial by 10 factorial is what I have written down. 10 factorial would be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Then these are all pairs that equal 1, right? And you're just left with that. So 12 factorial divided by 10 factorial ends up equaling just 12 times 11. So it seems like it would be easier to say it that way, but there's times when that's not really easier and that this is actually more effective. This is mostly used in counting methods, things like probability and such. Anyway, but it will show up in some of the things we're doing today. Alright, don't want to make this video too long, so maybe I'll stop. No, I'll keep going. Okay. So just before we get too far along, a sequence, typically when you hear the word sequence, you're looking at a pattern of numbers. There's a whole bunch of different ways to create a pattern of numbers. For example, there's a thing called the Fibonacci Sequence. You might have heard of that one, which is 1, 1, 2, 3, 5, 8, 13, 21, 34. I don't know how many of you remember having learned that before, or if you have. But what it is you start with the numbers 1 and 1, and then you just start adding them to get the next one. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8. And it's actually kind of funny because this sequence actually appears in nature, in measurements and such. Kind of discovered by a guy named Fibonacci. Alright, so that's just to kind of give you a little introduction to what sequences are. Sequences can be all sorts of different patterns of numbers, and so if this was a particular sequence we were looking at, this would be the y value a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, a sub 6, etc. And it would go with the n value, or domain, of n equals 1 for that number, n equals 2 for that number, 3 for that number, 4 for that number, 5 for that number, 6 for that number, and so on. So you always have the natural numbers associated with the sequence because you're talking about a particular number in the sequence, like the first one or the sixth one or whichever. Okay, I promise this will make more sense in the next video.